Hello everyone, welcome back to Embedded System course practicals. So today we are going to study practical number 8. The title of this practical is Development and Execution of Program in C to display the message on LCD, that is 16 by 2, that means 16 characters, 2 lines. Okay, so on each line there are 16 characters. Such LCD is assumed, and on that display message. Okay, and this LCD is interfaced with 8051 microcontroller. Okay, so in short we can say that is this experiment number 8 is on LCD programming. Okay, so there are two ways to program LCD. To program LCD means to display message on interfaced LCD, and for that there are two ways of programming. First is sending command and data, that is programming LCD. So we are programming LCD means we are sending command and data. That data means whatever message we want to display, and command means to format that LCD as per our required configuration. Okay, so sending command and data to LCD with time delay. Okay, so this is the first method, in which after sending each command or data means one character to display on that LCD. Okay, so some minimum time delay is called. Okay, so that time delay is required to finish the internal operation of LCD. Okay, so for which we have issued command or data, okay, to the interface LCD. So LCD requires some time to take action according to the command or data it receives. Okay, so what we are doing, so we are giving LCD a sufficient amount of time to finish its internal operation according to the command or data we have given. Okay, and after that we are issuing next command or data to that LCD. So that is the first method. Okay, so there is an alternative to this first method, and that is the second method, that is sending command and data to LCD with checking busy flag bit. Okay, so inside LCD there is a control register in which command, okay, command we write normally command we write in control register or command register. Okay, so when we read that command or control register, okay, so we can read the status of uh, in, internal operation of LCD. Okay, and that we can check with the D7 bit, which is called as busy flag bit of that command register. Okay, so when we perform a read operation, okay, then we get whatever contents in command register, that is status of LCD, in which that is 8 bit. Okay, out of which D7 bit is called as busy flag bit. Okay, so we can check that busy flag bit. Okay, and we can see whether LCD has finished with its internal operation after issuing a particular command or data to that LCD. Okay, so by checking that busy flag bit, we can check the status of internal operation, whether it is finished or not, and after it gets finished we can send next command or data. Okay, so this is the second method. Okay, so second method will be fast, because in first method we are calling fixed amount of time delay. Okay, and it may happen that that is whatever command or data we are given to LCD, uh, so for that internal whatever internal operation that will happen, that may not require that much time as compared to the time delay we are calling after issuing each command or data to LCD in the first method. Okay, so we are going to study this first method only. We can also program LCD according to second method, but out of these two we are going to study only one in this practical. So for that we are going to study this program. So write a 8051C program to display the message hello on the LCD interfaced with 8051 using time delay method. Okay, so we are going to display message HELLO on the LCD interfaced with 8051 microcontroller. Okay, using time delay method according to the interfacing diagram shown here. Okay, so see here the interfacing between this 8051 microcontroller and LCD. Okay, so this LCD we studied is 14 pin LCD. Out of this, D0 to D7 are data pins on which we actually issue command or data to be written into LCD. Okay, so D0 and D7 pins of LCD are interfaced with pin number 0 to 7 of port 1. Okay, then RS means register select. So either we can issue command or data. If it is command, it should be written in command register. Okay, and if it is a data, then we should write that uh, into data register. So by using this RS pin of LCD, we can select. Okay, we can select that command register or data register in which the whatever data we will output on port 1 that will get written. Okay, then next pin is, so this RS pin is connected to pin number 0 port 2. Okay, RW. Okay, so this pin is used to specify whether the operation is read or write. Normally operation is write. So in second method of sending command or data to LCD, we normally perform read operation. But in this program, since we are using time delay method, this operation with LCD will be always write operation. Okay, then enable. So this is the enable pin which enables. Okay, so when this enables, that data will get latched on this D0 to D7 pins of LCD. Okay, then other pins. So these pins are interfaced with pin number 0, 1, 2. Okay, so this pin should be configured as output 0, 1, 2 of port 2, and these pins of port 1 should be configured as output. Okay, so both all these pins should be configured as output in this time delay method. Remaining 3 pins of LCD. Okay, VCC, VSS supply voltage pin. Okay, and V is used to control the uh, brightness of LCD or intensity. Okay, so for that, uh, 10 kilo ohm potentiometer is connected in between this VCC and VSS. Okay, and variable terminal of that potentiometer is connected to V. So if we vary this variable terminal, okay, of this 10 kilo ohm pot, then that intensity of LCD display can be varied. Okay, so according to this interfacing diagram, we have to program or we have to write the uh, program, okay, to display message hello on this interfaced LCD. Okay, so now we will move towards program. So program is already written and it is open in a kill compiler. So this is the program. So program file is prog1.c. It is in a prj8. Prj8 means project number 8. Okay, that is the name given to this project. Under this there is one C file in which I have written the program for that LCD. Okay, so this is the title of experiment number 8. This is the title of program. Now we will start discussing this program. So as usual, uh, we will first include reg51.h header file. Okay, then uh, there are 3 declaration of functions. Okay, we are using this function. So first function is void LCD CMD, to which I am passing one value. Okay, that is in value variable of type unsigned char. So see the name of this function. LCD CMD means this function, okay, is used to send command to interface LCD. That is the meaning. Okay, the next function is LCD data, to which again we are passing unsigned char type of value. Okay, then this LCD data is the function. Okay, so that will write data into LCD. So the program is written inside this function that will write data into interface LCD. That is the message to be displayed. So each character from that message we can write by using this LCD data function. So MS delay, that is used to generate the delay in millisecond of a value that we are passing to this function. Okay, so to which function I am again passing the value that is of type unsigned integer. That is from any value from 0 to 65,535 we can pass to this MS delay function. Okay, and this MS delay function will generate delay in millisecond according to the value we are passing to this function. So we have already studied this function. Okay, so these are three function declarations. Next, we are declaring one L data as SFR type of variable, in which to which I am assigning address 0x90, which is the address of port 1. Okay, so that means we are representing port 1 by using symbol L data. That is in simple, we can say. Then, so this is port 1 is interfaced with LCD data pins. So we can refer to LCD data pins as L data. Similarly, port 2 pins 0, 1 and 2 are interfaced to RS pin, RW pin and EN pin of LCD. Okay, so in this program, what we are doing, we are assigning address of pin 0 of port 2 to S bit type of variable, that is RS. Then address of pin number 1 of port 2 to S bit type of variable RW, and address of pin number 2 of port 2 to S bit type of variable EN. Okay, that means we can represent these pins by using symbols RS, RW and EN in the remaining program. That is the thing. Okay, now next main function, void main void, it is starting here and this function is ending here. Okay, so inside this function, what I am doing, I have to display. First, I have to configure LCD as per our requirement. Okay, and then I have to continuously display message hello, HELLO on the LCD. Okay, so for that, see these three statements. So these three statements are making pins of 42, pin 0, 1 and 2, that is RS, RW and EN. Pin 0 means I'm actually configuring these pins as output. Okay, next, while one means infinite while loop, means whatever statements inside in this while loop, that is from there to here. Okay, so from here to here, that will continuously repeat or infinitely repeat. Okay, that means here inside this while loop, what I have written, um, program that will configure LCD and display message HELLO on its display. Okay, now see the program. So LCD CMD, this is the function that will write command into LCD. So that function I am calling, and to this function I am passing value 0x38. Okay, so 0x38 is what? It is a command, because I am calling this LCD CMD, means I want to write command to LCD. Okay, and what command I am sending? Command is 0x38 and meaning of this command is fixed. And what command? This is the command to initialize LCD 2 lines. That means 16 by 2 with 5 by 7 matrix, means the character will be displayed by using 5 by 7 pixels. Okay, or dots. Then after issuing this command, I am calling this delay of 250 milliseconds. Means I am giving LCD to finish time to perform its internal operation according to the command I have given. Okay, so I have given command 38, means to initialize LCD 2 lines 5 by 7 matrix. So to finish this operation, LCD will require some time. Okay, and I am giving time to LCD. So 250 milliseconds is much sufficient. Okay, to finish that operation. In this way, after issuing each command and data, I have to call this MS delay function with 250 milliseconds delay. Okay, then LCD CMD 0E0, again I am issuing command LCD CMD 0x0E. Command is 0E, means it is command to turn LCD on and cursor on. Okay, so when LCD is given with this command, it will perform its internal operation. And what operation? It will turn on LCD and it will turn on cursor. Again, I am giving LCD time to finish that operation. And again, I am giving these commands. Okay, so these are 3 more commands I am given, due to which command, this first command 01 will clear LCD. The second command will move cursor to right. Okay, and this third command 86 will move cursor to line number 1, position number 6. Okay, so there are 16 positions on each line and we are moving to sixth position. That means we have to display message from 6th position. Okay, so these are the commands. Next is, see what? LCD data. Now I am using function LCD data, and to this I am passing what in single quote H means first character from the message I am um, giving to LCD. Okay, so since the function is LCD data, now this will be assumed as data and it will get displayed on LCD. Okay, and then to display that character, that is H, LCD will take some time, and we are giving that time by calling ms delay function. Okay, which will provide us 250 millisecond delay. Okay, in this way, see here, first we are passing H, then we are passing E, then we are passing L, then we are passing again L, then we are passing O. And after each issuing each message character, we are calling this ms delay function, which will provide some delay so that LCD will perform its internal operation. Okay, in this way, this program in main function uh, will configure interface LCD. Okay, and then it will display the message. Now we will go into these functions, that is LCD CMD and LCD data. Okay, so see here, first is ms delay function that you already know, then LCD CMD function. Okay, so to this LCD CMD function I am passing the command. Okay, so that command in variable value. So first statement is L data is equal to value. Okay, means that command I am giving, I am assigning to L data. And what is L data? L data is nothing but it is representing port 1. And port 1 is interfaced with D0 to D7 pins of LCD. Means what I am doing, I am whatever command I want to issue, that I am outputting on port 1. Then I am making RS pin 0. RS pin 0 means that is a whatever data I am giving to LCD. Okay, that will get written into command register. RS register select means it will select command register because I am issuing command. So RS should be 0. Okay, then RW is equal to 0 means I am specifying it is a write operation. RW is 0 means write operation. Then I have to make EN pin 1. Okay, so again I have to make it 0 after very little time. Okay, so that means I'm generating a high to low going pulse on EN pin that will latch whatever data outputted on port 1. Okay, so port 1 pins are connected to data pins. So whatever data that is there on port 1, that will get latched inside LCD into command register. When the enable pin we make, that is high to low going, then that data will get latched inside command register. Okay, and then we are returned. Okay, from this function. So once that command gets written in command register, LCD performs its operation. Okay, so this is the LCD CMD function which will write command into command register. Similarly, this is a LCD data function which will write data into data register of LCD. Okay, which is going to be displayed on display of LCD. Okay, so to whatever data we want to display, that is a single character at a time, we are passing to this LCD data function. Okay, so that is there in value. Okay, so the first statement inside this function, what L data is equal to value. So that character, ASCII code of that character, we are passing to that function. Okay, so so that value we are outputting on port 1. Okay, then we are making RS pin 1. Okay, because now we are going to write that character. Okay, we are passing to this LCD data function. Okay, into data register. So we are selecting data register by making RS pin 1. Then RW pin we are making 0 because this is the write operation. And again we are generating a high to low going pulse on EN pin. Okay, so to latch whatever data is there on port 1. Okay, inside LCD's data register. So once we generate this high to low going pulse, that data will get written into data register and that will get displayed to the current cursor position. Okay, so these are LCD command and LCD data functions. Okay, which will be called from main function as per requirement. So initially LCD CMD function is called, and then to display message hello, LCD data function is called. Okay, so now we will build this program so there are no errors. Okay, now I will debug this program. Okay, So see here, this is the port 1 to which LCD data pins are interfaced, and this is port 2, out of which pin number 0, 1 and 2 are interfaced to RS, RW and EN. So first we are making these pins as output. Okay, so see here, this is 0. So here we should also make this port 1 as output. Okay, let us do it. I will start this debug session, and first I will make L data also. L data is equal to 0x0, or simply 0 I can write. Okay, L data. L data is nothing but that is port 1. Okay, so I will again build this program, no errors. Okay, so again I will go in debug session. Debug session. I will start debug session. Okay, so see here, first I will make port 1 as output. Okay, so output 0 0 is written in port 0, and then RS, RW and EN pins. Okay, we are making 0 to configure these pins as output. So we have configured port pins. Then LCD CMD. Okay, so this function to which I am passing command 38. Okay, so which will initialize LCD in 2 lines with 5/7 matrix. So I will go inside this. Okay, L data. Okay, means that data 38 will be outputted on port 1. Okay, so see here. So that is outputted 38 on port 1, to which we are assuming that D0 to D7 pins of LCD, data pins of LCD are interfaced. Okay, then RS we are making 0, means this is command. Then RW is 0, means we are going to write this. Then we are making EN pin. See, now we will make EN pin 1. EN pin means P2.2 pin 1 and 1 millisecond delay. Okay, after that I'm making again it 0. Okay, means we are generating high to low going pulse on this EN pin. Then this function execution ends, and then delay of 250 millisecond. Okay, so after this what will happen? So that LCD interface to port 1, okay, of 8051 will be configured as 2 lines with 5/7 matrix. Similarly, these commands will get executed. I will skip this. Okay, so see here, it is being outputted on port 1 commands. Okay, so 606 is outputted with after that delay. Then 86 is output delay. Now LCD data function. So to this LCD data function, we are passing a character H to display it uh, on the current cursor position. Okay, now we will go inside this LCD. Same. Okay, so whatever character we are going to display, that we are outputting on port 1. So see here, first H character. Okay, its ASCII code is 48. Okay, it is outputted on port 1. Okay, then we are making RS1 because we have to select data register. Okay, because we are going to write into data. Okay, so we are making RS1. Then RW we are making 0 because it is a write operation. Then we are generating high to low going pulse by using this. First I'm making this EN1. Okay, then okay, so that is okay, so here 48 is outputted on port 1, and that is get latched inside LCD into data register, and that is now displayed on LCD. Here we cannot display LCD. Okay, because this is simulator. So actually when you will interface LCD the way I show to you. Okay, that is port 1 is interfaced with D0 to D7 pins, and port 2 pins are interfaced to RS, RW and EN pins. Okay, then if we write the hex file of this program into program ROM of that 8051, okay, then it will display this HELLO on its display. Here right now I cannot display that LCD. I cannot simulate LCD here, LCD display here. Okay, so next is E. Okay, I will. Okay, so that is outputted. That is ASCII code of E is 45. That is outputted to port 1, and I'm calling. Okay, So that is latched inside data register, inside this LCD data function. Okay. So in this way, HELLO will be outputted, okay, on port 1 and latched into data register, and it will get displayed on LCD starting from the selected cursor position. That is position number 6 on line number 1. Okay. So in this way, this program is displaying this uh, continuously. HELLO message continues. Okay. So we have simulated this uh, program. Okay. I cannot directly see the output, that is LCD display. I cannot display here because this is simulator. Okay. So for that, on the kit, we have to write this hex file into 8051's program ROM, and then we can see the output. Okay. So this is LCD interfacing program. I will send you the write-up of this practical. Okay, you can modify that according to the program we studied. Okay, and you have to submit. So we have performed 8 to 9 experiments. Okay, so that is sufficient. You can finish your submission. You prepare all the write-ups as per sequence. You can add index page, you can add certificate page, and uh, prepare it and wait for the message from department. You have to submit it. Okay, you have to submit it. Otherwise, if you don't submit it, there might be problem. Okay. So okay then. Okay, so this is about experiment number or practical number 8.